Hi everyone. Um, in the last Arena video, I just briefly went through the different sections of the Arena window. So in this video, I'm just going to go through the modified version of Model 3-1 that you can have downloaded off of our class website. I just want to apologize in advance. I am sick, so my voice sounds a little hoarse, or if you can hear me, I have a cough drop in my mouth. Please ignore such distractions. So let's just start by taking a look at this model. In the center of our screen, we see there's a flowchart of the system. So before we start going through this, let's go ahead and click on Basic Process because everything that's in this model is in this Basic Process template. The first shape that we can see, this shape, this is a Create module. So I'm going to double click on it. The name of this module is Parts Arrive. The entity type, the name of the entity that is coming into the system at this point is called part. The time between arrivals, that is the inter-arrival time, has been fitted and found to be best represented by an exponential distribution with a mean of 15 minutes. Remember that when we talk about exponential distributions, sometimes we describe them by its lambda parameter, which is 1 over the mean, and sometimes we describe it by its mean. In this case, we don't want to get confused. So this value that Arena is asking for is the mean of an exponential distribution. We have one entity per arrival, so every time this module is activated, one part enters the system. There is no cap on the number of parts that can enter the system, and the first part enters the system at time t equals 0. The next module in this system is this process module. You can see this is this square shape. So I'm going to double click on this. And the name of this module is Drilling Center. Here where it says logic, the action is a seize, delay, release. So that means that anytime an entity arrives at this process and this process is activated, it's going to seize the resources in this list, which at this point just says drill press 1. So it's going to seize one drill press. There's a delay, which is the process time. And when this process is over, it will release this drill press for another part to enter this process module. So we can go and click on Edit and take a look at this drill press resource. This is a resource. It's a single resource, not a set of resources. The name that's it's been given is drill press, and we need one drill press to be free in order for this process to run. Down at the bottom, we have the delay type says expression, minutes, value added. So we have some standard expressions that are coded already into this process module. For example, if it's a normal distribution, we can just put the mean and standard deviation. But if it's anything other than a constant, normal, triangular, or uniform distribution, we can type the expression in using Arena syntax. So in this case, we see that the expression is expo 8, and we'll cover the syntax for various different functions in Arena. So can close this. And then the last module here is this Dispose module. You can see that the shape matches. It says parts leave system, and it says record entity statistics. So what happens is that as parts leave the system, this module will record the time that this entity leaves and the time that it arrived, and it'll also keep track of the times that the entity was waiting, when it was in a value-added process, when it was in a non-value-added process, if it was being transferred anywhere. It will have all of those statistics, and those will get recorded. So we can click OK. In this model, we also have some animation, which we'll talk about later, and some plots, which we will also talk about later. If we hover over these, we can see that this is the resource picture for the drill press. This is the queue, the drilling center queue. This plot is the NQ drilling center queue. So this is arena syntax for the number N in the queue, NQ, of the drilling center queue. And this expression is NR drill press, which is number of resources of the drill press in use. So this is now showing the number of parts waiting to be processed and the number of the drill presses busy. The rest of these modules in this template are not used in this model. This is a very simple model. It's the most simple model you can get. It's just a single process with a create and a dispose. So if we scroll down, we are not using any of these other symbols, but we do have some information that is not captured in the flowchart view, and that is information in the spreadsheet view. So if we click on attribute, there's nothing here. Entity, we have one entity defined. It's called a part, and we have assigned the picture of this part to be a widget. So this can help us keep track if there are multiple parts in our system. We can assign them each a separate picture. Next is this queue. This is the drilling center queue. And by default, the queue is always a first in, first out queue. But depending on your process, you can also choose other types of queuing mechanisms. There is a resource here that's been defined as a drill press. And this drill press has a fixed capacity. That means that the number of drill presses doesn't change throughout our simulation. An example of something that would not have a fixed capacity would be, for example, manpower. You might have more people scheduled to work during high peak hours and less people scheduled to work on off-peak hours. But in this case, we always have the same number of drill presses. We have a fixed capacity, and that capacity is 1. If, for example, the company wished to purchase a second drill press, we would then change this to capacity 2. It's as easy as that. So let's just change this back to 1. And we don't have any variables, we don't have a schedule, we don't have any sets defined. So this is a very simple system. Let's try running this. So we can go to Run Setup, and we can set these replication parameters. We can say that it's one replication. So that means that n equals 1. We're going to run the simulation once, but the simulation itself is going to last for 72 hours. It's a 3-shift operation, so there's 24 hours per day, and we want to collect our statistics in minutes. We want to see average wait time, average time in system. We want to see process time. We want to see all of those times in minutes. We'll have our base time as minutes, and we'll click OK. And then we can go ahead and hit play, or we can go to run, go. Either of those work. Let me slow this down. So we can watch this running, and we can see the drill press is in use. It's not in use. The queue builds up if the drill press is busy for a long time. We can also see down the status bar how many minutes have elapsed since the start of the simulation. And a key point to notice is that this clock is not running continuously. This clock is jumping from a single point in time to another single point in time because this is a discrete event simulation. So we only keep track of the time when certain events happen. So these events are when things start and when things stop. So when things arrive, when things leave, points in time when our system evolves. So if we look here, the simulation has run to completion. Would you like to see the results? Yes, let's take a look. So we can open this up. By default, our category overview report has 3 sections: entity, queue, resource. The entity shows us the average value added time, average wait time, and then average total time in system. We see the parts that came in, the number of parts that were that exited the system, and on average we had 1.4 parts in the system. We can see that the maximum or the minimum value is 0, so that's when no parts are in the system, the machine is idle. Maximum value is 10. So in this case, since it's only a single process, that should imply that there is 1 part being worked on and 9 parts in queue. We can go to the queue tab and see that the average wait time in the queue was 11.96 minutes. The average number waiting in the queue was 0.83. And if we come down here and we look, we can see that the maximum value for this number waiting is 9. So that's in accordance with what we saw on the previous page. And then the last section is the resource section, where we can see the utilization of our resources. So the drill press was used 58.6% of the time, and then the rest of the time the machine was idle. So these are all metrics that we can use to assess the performance of our system. But if these statistics are not sufficient, or you're trying to record something that's not given to you by default, we can always define our own statistics for data collection, and we'll get into how to do that. So now that we've run the simulation, let's stop it and go to Run Setup. And this time, let's do this for 10 replications. So we'll hit play. And I really don't want to sit through 10 replications at this speed. So let me just speed things up. We're on our 3rd replication, 4, 5, 6, 7, 8, 9, 10. Let's look at the results. But we have here all of the same metrics, but now we have some plus or minus confidence interval. And this is this half width is given to you for a 95% confidence interval. That is Arena's default. If you want to change it, you would have to specify that somewhere else. But by default, Arena gives you a 95% confidence interval. And all of the numbers are fairly similar to the first run. So you might be asking, if you have been following along, if this is all random sampling, if these are all random distributions, why do we all have the same numbers? And that's because Arena actually controls the randomness. These random numbers are generated prior to running the simulation. They're part of the software, so that every time we run the same model, we get the same random data, but it's from replication 1 to replication 2, there's no correlation. And from replication 2 to replication 3, there's no correlation. But from my replication 1 to your replication 1, those are identical. And my replication 2 and your replication 2 are identical. So that's how we can get the same numbers, but it is also still running a simulation as random trials. So let's try building this model on our own. Let me close this report and go to File, New. So referencing the lab, we know that parts arrive, they go through a process, and then they leave. Parts arrive, say parts arrive. The entity that's arriving is a part. The inter-arrival time is an exponential distribution with a mean of 15 minutes. One entity per arrival, maximum arrivals is infinite, first creation at time t equals 0. We know that this process is drilling station. And since there's a drill, that's a resource, we can say that this is a seize delay release. We're going to use the resource for this process, and then we're going to release the resource to be used by any other part. And so this resource is the drill press. And it takes one drill press to run this operation. The delay is an expression. The units are in minutes. It is value added. And so now, if you know the Arena syntax, you can just type it in directly. But especially in the beginning, if you don't know the syntax or you're worried about making a typo, we can right-click and go to Build Expression. And we can say that we know that this is a random distribution. It's an exponential distribution with a mean of 8. And so it will update the expression down here. And if we hit OK, it will insert that into this field. So now we have our exponential distribution. And you can see that this queue automatically gets generated when we create a seize delay release process. And then the last thing is that parts leave. We have our entity part, and we want this to be maybe a picture of a ball. We have our queue for our drilling station. It's a first in, first out queue. And we have our drill press. It's a fixed capacity. There's one drill press. And we have no variables, no schedules, no sets. We don't have to worry about pictures. So let's go to our run setup. Let's do 10 replications. The replication length is 72 hours. There are 24 hours per day. We want to calculate our statistics in minutes. And then we can also go here and add some project parameters. This is just a name and a description. So we can call this model 3.1. Analyst is me. You can change this to your name if you'd like and say this is an example. And these are the default statistics that are collected. And we don't need to know about any of the other ones. So we're fine with just these 3. We can hit OK and then play. And then again, let's speed this up all the way. Now notice that we don't have the animation of the drill press. We'll learn how to insert that in later. Let's look at the results. And we should have the same numbers, 305 out. It should be 9 something for the weight, 8 something for the value added time, 17 something for the total time in system, etc. So you can compare these 2 reports and verify that the 3-1 that you create is the same as the 3-1 that's been uploaded to Carmen. So that's something that you can do on your own. And that's pretty much it for building a very simple process. I hope that this video was helpful and you can use this for your homework this week. And I will see you guys next week in lab. Bye.